We back to EEG. So we had this 16 channels data that we were looking at before. Now we're just back to the standard 2-channel thingy. And we had the bot making this thing for us. This was done using combination of what will we have in GitHub Copilot, Claude 3.5, 3.7, 3.7 thinking model. We also have Gemini, Google, GPT-4o. It's the default O1 and O3 mini. Not sure which one's better. O3 mini is much quicker. O1 is one of those big reasoning models that's just taking much longer. Yeah, so we had this issue with the window size drop down, so we're navigating these 2 EEG channels. Yeah, this buttons looks pretty good. We can have another level of it. Yeah, there's a lot of things. We don't want to make it like standard thing. We just want to see how far we can push the bot for it to actually develop it itself, as if it was the actual expert developing these things. So we're doing vibe coding, so we're just gonna accept the changes. Let's see if we play 0.5 speed, change to okay, 20 seconds actually stops. 20 seconds, 20 seconds, yeah, that looks correct. So it was able to fix the problem. It's the Sonnet thinking model. Let's start a new chat. So we have both edit with Copilot. We'll place it, we'll do one of the smaller models for this. Let's do 3.7 Sonnet and let's just chat with it quickly. So we have this Main.js and yeah, just a quick one. Okay, just a quick response. If you had to get rid of one of the features in the JavaScript, what would it be?
I would suggest removing the dropdown for selecting the window size. This feature allows users to change the window size.
Okay, without the code response. No, I actually like that feature. There was another something with the zooming and dragging that doesn't work really well, so we either need to improve it or get rid of it. What do you think?
If the zooming and dragging feature is not working well, it might be better to remove it for now to improve the user experience. This will simplify the interaction and avoid potential frustrations for users.
Okay, so supposedly you can just edit with Copilot. Menu select the request. There's only one. I know the what to. What I do? Yeah, the what to. Okay, it will be the last one. Okay, it's removing the zooming. No, discard. Just moved it into... okay, still learning how to use it. Move these 2 files. 3.7 Sonnet, I don't know. Which one is better? Well, which one's quicker in this case? Let's try Gemini for a sec. We had some success with it before. And the potentially more precise sliding, but yeah, we'll move on into a frequency domain of this thing as well. Okay, so just commenting out code and updated the HTML, which is great. Okay, so it's removed that successfully, but it's removed the other stuff as well. Okay, so Gemini 2.0 is not great. Let's do 3.7 Sonnet. So the good thing about it is that we can select a different model and redo the last response. It will ask us that we're reverting 2 files back to its previous state, which is okay. So it's actually a nice indicator there, nice and simple. 2 insertions, 3 deletions. Yeah, 1 deletions as well, don't we? So it's finished the edits. I have to save the file. Okay, that's much better. This 3.7 Sonnet. And this specific particular task is better than Gemini 2.0. Thank you very much. Yeah, I like how to play. When you play 0.5, yeah, there's something weird with this data. It's two channel. Oops. There's something wrong. You can scroll like half a window, is it? What just happened there? It says 30 seconds, but it doesn't look like 30 seconds. Okay, 5. Let's go to the beginning, 5 seconds. Yet the location of this thing should just stay where it is, isn't it? Why it's going? It's going default to the middle. Is this going default to the middle? Okay, let's see. 3.7 Sonnet is promising. Yeah, let's chat with the thing first? No, there is the thing in the code that sends the timing to the middle, the pointer to the middle of the file. Can you just explain this first before changing the code? We are in the editing the code mode, so I wouldn't be surprised if it will start editing.
I'll explain the code that positions the EEG visualization at the middle of the recording when it first loads. Explanation of mid-recording positioning. In the current code, the visualization starts by displaying the middle portion of the EEG recording rather than the beginning. This is a common practice in medical visualization to...
Okay, that's fine, but can we actually just make sure that when the page loads, it's loading the middle, using the middle pointer, but when we're actually doing other things with the, with the sliding, moving around the file, changing the window size, it should not revert back to the default middle pointer option anymore. Do you know what I mean?
I understand what you want. You'd like the visualization to initially load at the middle of the recording, but when users interact with the controls, like the slider, window size dropdown, etc., it should maintain the current position without reverting back to the middle. Let's modify the code to fix this issue.
It doesn't know what I meant. It doesn't understand. Single prompt shot, whatever it's called. And so it's added position tracking. Updated the slider to use the track position. Very nice, very nice. Modified the window size. Change handler to maintain the current position. Okay. Make sure we update the visualization with the maintain position. Yes. Update the view with the current time position. Sounds very good. Yeah, I wanted 0.5 speed, play speed as default. The code is getting extremely long. We are vibe coding, so I'm not gonna read any of it. Just gonna accept. Yep, the way to test it. Yes, we're loading the page. It's loading in the middle. We're doing play, this and that. Changing the window size, yeah, and the pointer stays in the same location. Yes, so 3.7 Sonnet seem to be having better luck with it. Yeah, what do you think those are? It's just some bad recording. Yeah, probably like chatting with all three mini. Okay, if you had to split the JavaScript file, how many files would you split it into?
Based on the functionality in the excerpt, one possible split would be into 3 files. One for UI components and event handlers, e.g., handling play/pause button and selectors. One for playback logic, e.g., timing intervals, step calculations, time window updates. One for shared utilities, e.g., data processing functions, helpers. This separation would improve modularity and maintainability.
Again, how about loading the data, Main.js, and then we have the scrolling functionality.
Based on the responsibilities in Main.js, you could split the code into at least 4 files. One for data loading functions, e.g., fetching and parsing data. One for scrolling functionality, e.g., handling scroll events and interactions. One for playback logic, e.g., managing play/pause intervals and updating the time window. One for UI components and event bindings, e.g., building selectors and wiring up buttons. This separation would enhance modularity and ease maintenance.
Okay, it sounds like, loading the data, parsing the data is a definite one. Then we have the scrolling functionality and playback logic. Can those two go into the same JavaScript file? And then we'll have the Main.js that call these two, the previous two, and also deal with all the UI components and event bindings. How does that sound?
That sounds like a clear separation. Loading/parsing goes in one file, scrolling and playback logic in another, and Main.js handles UI and event bindings, orchestrating the other two.
Okay, so can you write a clear instruction prompt for another developer?
Create a new file, e.g., dataloader.js, that handles all data loading and parsing functionality. Create a second file, e.g., playback_and_scroll.js, to combine all scrolling functionality along with playback logic, e.g., the set interval playback timer and update functions. In Main.js, Limit the code to UI component rendering, buttons, selectors, etc., and event binding. For example, retain the code that creates the playback button and selectors, but move the logic inside the click handler into calls to functions.
Yeah, we did absolutely right. So we'll choose the 3.7 Sonnet thinking. You can use your keyboard left and right. Hey, can you just review the code without making any changes? So we now have the 3 JavaScript files. They seem to work okay. There seemed to be some problem with changing the window size again. We had this already before. Can you just have a look without changing the code? So that's the smallest.
I'll review the code focusing on the window size change functionality across the 3 files. Window size change flow asterisk. The issue likely occurs in the chain of events when changing window size. User selects new window size in Main.js add navigation controls. This triggers the select elements change event handler. It updates the slider and calls create EEG visualization with new window size. Then calls add navigation controls, again recursively. Potential issues asterisk. The current window size in Playback and scroll.js might get out of sync. Every window size change recreates all controls including the window size selector. This recursive control recreation might cause event handler duplication. The playback state isn't properly preserved during window size changes. Critical points asked.
Okay, can we actually try fixing this without breaking anything else? So that's the same model, 3.5 Sonnet. It's one of the smallest ones we've
Here's
got.
a focused solution to fix the window size change issue without major refactoring. Step-by-step fix. The core issue is that we're recreating all controls when window size changes. We should update only necessary components. Need to ensure window size state is properly synchronized. Prevent recursive control recreation.
It seemed to know what it's talking about. Let's actually see if it's working. It seemed to work. Very nice. So it's Claude by Anthropic. Thank you very much. What should we do next if we're still staying in the time domain? Yes, it's just reviewing the file. Oh, quite a bit of memory usage. What happens when we load the page? Yeah, it is loading the entire file, doesn't it? Hey, can we use 3.5 Sonnet and reorganize? Hey, can we actually restructure the file and folder structure for this folder? So I want the JavaScript to be in a separate folder and the PDFs in a separate folder again. Can you do it? The data can stay in the main folder. That should be fine.
I'll help restructure the project folders. Here's the new folder structure. Bionic Chaos Site /anesthesiology/ index.html data /
I did put the data in a separate folder even though I asked it not to, but that's okay. What that failed, let's just go for GPT-4o for this quickly and redo. Yes, should put everything back as it was in theory. Yep, and it will break. Because GPT-4o is not that smart. Okay, I can bring the big gun. 3.7 Sonnet thinking. Redo the thing. Yes, should bring everything back. Okay, that looks legit. Updating index HTML. Okay, update the folder. What? Why are you being lazy? Why are you being lazy? And now reverting back will be a pain. Yeah, we broke it. Just the data is just 2 columns of 2 EEG channels, and you can assume the sampling rate is 256. Just a quick response. Are we loading the whole data set? Is that correct? Not just the one file?
Yes, that's correct. The function fetches the entire CSV file, then processes all of its content.
And the file is just 7 megabytes. However, we have more than 100 megabytes loaded in the browser. Hey, can you explain why that might be the case?
It sounds like the parsed CSV data is being transformed into a larger in-memory structure than its raw 7 megabytes file size, which can result in 100 plus MB being allocated in the browser. This may happen if each CSV row is converted into an object or array, and if there are many rows, or duplicate copies are made, the memory overhead increases significantly.
And no, there's no overhead. We seem to be loading correctly. There's no repeated, just two columns of EEG, one for each channel of EEG data. So can you guess why the memory in the browser is so much larger than the actual file?
Browsers use many small objects and underlying structures when parsing your CSV text. Even with just 2 values per row, each row is converted into JavaScript arrays or objects, which adds overhead compared to the raw text size. In addition, JavaScript numbers, double precision floats, and the engine's internal data structures, like hidden classes or metadata, can balloon the memory footprint significantly versus the original 7 megabytes file.
Can you look at the entire code base and double check? The original file is CSV. Can we also make comments if we should be converting it into JSON or something?
The code definitely expects a CSV. You're reading raw text, splitting on new lines and commas. Converting to JSON would require an extra step, parsing CSV, then serializing to JSON, and wouldn't save much unless you pre-convert the file on the server so the browser doesn't do the parsing work at runtime. My recommendation is to keep CSV if the pre-processing cost is acceptable. Otherwise, consider pre-converting the file to JSON and serving that to reduce browser parsing overhead.
Okay, so how do we parse on the server into JSON?
Here's an example of converting a CSV file to JSON on a Node.js server using the x.json library.
Why do we need the Node.js? Should we just do it in Python without actually installing anything?
If you already have Python available, you can convert CSV to JSON using built-in libraries without installing extra packages. Here's an example. Import CSV, import JSON, CSV_.
Okay, and this Python code ensures that the data remains intact?
Yes. The Python code reads the CSV file and converts each row to a dictionary using csv.dictReader, ensuring that each value is transferred without alteration into the JSON output. This approach should preserve your data intact.
Okay, can we update the code to use the folder structure above and write the new JSON file into the same data folder?
Solution for updating pre-processing script to use folder structure. I'll modify the script to use the correct folder structure. Reading.
The original CSV file is just 2 columns, one for each channel of EEG. Can you adjust this Python code accordingly?
I'll modify the code to handle a CSV file with just 2 columns for EEG channels. Let me explain the approach step by step. We'll update the code to parse a simple 2-column CSV. Ensure each row is properly formatted with channel identifiers. Convert this data into a more structured JSON format. Preprocess.py. Modify the code to process.
Above is the sample, the first 10 lines of the CSV file. Can you adjust the code so it works with this sample?
I see the sample data has headers and the values are integers. Let me modify the code to handle this format correctly. Preprocess.py. Update the.
I'll redo it with all 3. I'm not convinced that it's much better. I'm not convinced that the generated EEG JSON file is much better. I don't think it doesn't look more efficient than the original CSV file. Can you suggest why that might be the case?
You're right to question the efficiency of converting the CSV to JSON in this case. The JSON format isn't necessarily more efficient for several reasons. Increased file size. JSON is more verbose than CSV because it repeats field names for every data point. It adds syntax elements like braces, quotes, and commas. The indent equals 2 parameter adds white space for readability, but increases size. Limited transformation. The conversion is very basic. Simply mapping CSV columns to JSON properties. Adding sequential IDs that don't provide much value. Not leveraging JSON's ability to represent hierarchical data. EEG data characteristics. Time series numerical data like EEG readings often work well in CSV format since it's column-oriented and efficient for uniform numerical data. Tools for scientific/signal processing often work directly with CSV. To make the JSON more useful, you could Store channel data as arrays instead of individual objects. Add metadata about recording parameters, sampling rate, etc. Group data by time segments or events. Include processing information or annotations. If you're concerned about efficiency, consider either keeping the CSV format or implementing a more sophisticated JSON structure that better leverages the format's strength.